So the question 43, this time the batter hits a ball toward the second base. This is a different story. At 80 feet per second and runs toward the first base at the rate of 30 feet per second. At what rate does the distance between ball and the batter changes? Well, okay, always start. Well, sometimes you can postpone drawing a picture, but it's always good to start with a picture. So what happened was that the batter hit the ball. Ball is going that way, and the speed was 80 feet per second. And the batter himself or herself is running that way with the speed of 30 feet per second. Now the question is, what is the distance between, what is the rate at which the distance between the batter and the ball changes? Again, the identification of the quantities, distance between, actually I can take exactly same quantities that we had before, copy, and bring it up here, because the question basically asking same kind of question. So the problem asking same kind of question. So the variables and the quantities involved in the questions are the same. Okay, so that's it. And again, we know that dx dt is 30. This is x, this is y, this is l. dy dt is 80 feet per second, and we are looking for dl dt when it's here given. When the runner has covered 1/3 of the distance between the home and the first base. So when the x is 1/3 of the distance between the home and base, well, it is given in the question, it's 90 feet, and 1/3 of that, it means that when x is equal to 30. Next, what about the relation between these two? Okay, here what you need to first notice is that the triangle we are working with is not right triangle anymore. And to find the relation between x, y, and l, you cannot use Pythagorean theorem. In other words, you cannot write x squared plus y squared is going to be equal to L squared. This is not, oh, I should have written the other way. L squared equals x squared plus y squared is not true anymore, because the triangle is not a right triangle. But generalization of Pythagorean theorem is what is called cosine formula. Cosine formula says that if the angle between x and y is theta, the relation starts like this. L squared is equals to x squared plus y squared minus 2xy cosine of theta. Well, what is theta here? In this case, you see this is a square, and then you have the diagonal here. It means that the angle between these two sides is going to be divided into two equal pieces. That means that the theta here is pi over 4. And cosine of pi over 4 is root 2 over 2. So L2 is equal to x squared plus y squared minus root 2 over 2. I can cancel those 2's. It will be root 2xy. Okay, very nice. And then then when x is equal to 30, what will be y? So this is what you have to do, combine different things. When x is 30, since the battery was running with the constant speed of 30 feet per second, that means that we are considering the time to be 1 second. So if time is 1 second, then y would be 80 times 1, which will be 80 feet. And L, you can use this formula again, find that. So L is going to be root 30 squared plus 80 squared minus root 2 times 30 times 80. Whatever the number is. Okay, so now that I have that, well, I can go ahead and find the relation between the related rates. This will give me 2L dl dtl equals to d 2 dx dtx plus 2 dy dty minus, here I have to apply the chain rule, so it will be root 2 dx dt y plus root x dy dt. Now, if you look at this formula, we have all the values. Okay, something is not working now. Let me see when my so I should continue to add this thing, dy dx dy dt y minus root 2 dx dt y plus root 2x dy dt. So then plug in everything there and then basically find value of the L, which will be L equals divided by 2L dl dt. Sorry, dl dt is equal to 2 times L. I'm dividing these 2 to the other side, which is 30 squared plus 80 squared minus root 2 times 30 times 80. And then in the numerator, 2 times dx dt is 30, x itself is 30, plus 2 dy dt is 80, and y itself is 80 minus root 2 30 times 80 minus root 2 again 30 times 80. And you simplify all these works that you see here, feet per second is what you are looking for in this question.